optimization, and then you learn numerical methods in order to find it. But in calculus, we don't use those type of softwares. Okay, so we do it just using the idea of calculus. To find the maximum and minimum, we know that we need a function. We find the critical values, and then we test it with the first derivatives or the second one. Then we be able to find the max and the minimum. So what I'm going to do it is historically, this is the birthplace of calculus. So there are lots of abstract problems that is not going to be to do with your field. So I just give you one famous one from Fermat, just an abstract one for fun to get to know the idea, but we are going to focus on the problems that are going to be related to the social science or business. So as usual, we are going to have the revenue problem and the cost problem and the profit problems. So where are we going to, it's like the problem that we did before, but before we just find the rate of the revenue, okay, the rate of change, but now we are going to take the max and the minimum. So eventually it's going to be 3 problems. And out of 3, we give you 2 of them on your next quiz, next test, and usually we repeat 1 of them on the final, okay? It's not difficult. As soon as you design the problem, we already talk about the revenue function, profit function, you are very much familiar. So it's going to be just, previously we give you the numbers and we ask you to find the rate of change. Now you are going to find those numbers yourself, okay? So that's the idea of 3.4 and 3.5. So the title, as I talk about it, is going to be optimization problem, okay? That's it, optimization. It's going to be an easy case, but you got to be patient and write all the details for us. Sometimes it takes times, but nothing complicated. Okay, so what's going to be optimization problems? So as I talk about it, the problem in which you are looking for the maximum and the minimum, we call it optimization problem, okay? You know, if you do something, we call it operational research. In computer science, then you do quite a lot of this type of problems. Okay, so I start with the classic case, okay, to get the idea. This is classic, this is the first problem. It was solved by the Greek for the first time, okay? They didn't use calculus, of course. But later on, you know, it was just the beginning of calculus. It was done by Archimedes, Fermat, and eventually calculus created. Very easy. There are different ways to express this problem. So I just want to give you the original one by Fermat. This is it. So what was the problem is we have a piece of wire, okay, a piece of wire. So let me just explain the problem here. So this is the original one. After Fermat is a little bit different. I will tell you that one, but I simplify it for you. It depends when I teach calculus, 1, 2, 3, I change it. So a piece, we have a piece of wire. Okay, a piece of wire of length, let's say 8 inches. Of length 8 inches. And we are going to bend it. Okay, bend it into a rectangle. So a piece of wire of length 8 is bent. Okay, is bent into the shape. Okay, bent into the shape of a rectangle. Other version is, you know, you have a farm, for example, and your farm is a rectangular one. So what you do is you just use 8 inches of wire, okay, for fencing, if you like. So what we would like to do in the case of the fencing on this one, you want to make sure that you get best of it. So what you would like to do, you would like to cover, okay, your rectangle as wide as possible. So this means you would like to cover the area that's going to be a maximum, okay, for your 8 inches or 8 yards meters wires. Okay, so it's bent into the shape of a rectangle. So what we'd like to do is we'd like to find the dimension. Okay, which dimensions produce, which dimension produce the rectangle, which dimension produce the rectangle of a maximum area, okay, of maximum area. So that's a problem. So this is a situation that you're going to have. You see, we have a piece of wire. This piece of wire is going to be 8 inches. Okay. So what we'd like to do, we are going to bend it into a rectangle. Okay, we bend it and we get a rectangle here. You see, it's going to be the rectangle. The rectangle would have a dimension, X and the Y. Okay, so we want to do it so that the area of the rectangle would be a maximum. You know that the area of the rectangle, you see the area would be X times Y. So what is going to be the problem? The problem is going to be you want to find the X and the Y so that this quantity over here, X times Y, is going to be a maximum. Okay, so the question over here is going to be, find, okay, find of course positive numbers because they are dimension, cannot be negative. Find the positive numbers, okay, X and Y, so that this product of X times Y is going to be a maximum. Okay, that's going to be 1. So you get various number, okay, you get various values for the X and the Y. And you want to find the one that give you a product of a maximum. The way we are going to do this type of problem in calculus, the quantity that you want to maximize or minimize, you are going to call it a function because you need a function. Okay, you need a function to be to work with. So the important part is to define the function. So define f of x to be equal to the x times y. Okay, the one that you want to maximize. So from now on, you have a function. Okay, so what you can do is you can find the maximum of this function. You find out for each value of x, for example, this is going to be a maximum. The first thing that you have to take care of is you call the function f of x, but you have x and the y. So you have to change it. You have to change it to the function of x only. So you have to go back to see if you can find a relationship between x, y, and 8 that enable you to find the y. So as soon as you define your function, then you have to find that relationship. Okay, you say note that. Any suggestion? Can you give us a relationship between, remember that was the 8, that is the total wire. So what we did is we just bend that total wire into a rectangle. So can you think about a relationship between x, y, and 8? Any suggestion?
2x plus 2y equals 8.
Excellent. Yes, that's it. Yes, because whatever we did, you see this wire, we use the 8 inches to make a rectangle. So we use the wire for the, okay, this is going to be the perimeter of the rectangle. Okay, this is x, x, y, y. So we know that, yes, you are right. We know that the 2x plus the 2y is equal to the 8. Okay, so now we can use these, we can solve it for y. Okay, we can solve this one for y. So you can divide by 2 first. You see, divide by 2. So if you divide it by 2, that gives you x plus y equal to the 8. Then you can solve for y. So y would be 8 minus x. Okay, then you go back and substitute in your function. So your function f of x was x times y. So now we
Shouldn't that
change it.
be x plus y equals 4?
Oh, you are right. Yes, thank you. Is equal to 4. I didn't simplify that one. Thank you. Okay, so that give you 4. Yes, you are right. Okay, y equal to 4 minus x. Okay, so it's going to be x times y. So this is going to be x times y is 4 minus x. So if you multiply them together, that give f of x equal to the 4x minus x squared. Okay, 4x minus x squared, and of course, f of x would be, you know, we can switch it if you like, negative x squared plus 4x. You see, this is going to be your function. And of course, you know that the x is the length. So x cannot be negative. So we make a, okay, you make a note that this x must be a positive number. Okay, now we have a function. You have a function, your function is f of x. So what you would like to do is, you would like to find out for what value of x this function would have a maximum. It's like, you know, forget about everything we did so far. It's like this function is given to you. You want to find the maximum of this function. And this is calculus, we know that. You have to find the critical value first, or critical number. So you have to differentiate it, let it equal to the 0 to get that numbers that you are looking for, okay? So it's important to get the function, first. Your case is going to be easy because your function is going to be revenue or the profit function. But this is the way I'm going to do this one to get these numbers done. Any questions so far? So we have to design the function of itself. Now, from now on, calculus, differentiate. F prime, okay, if you differentiate it, so f prime of x is going to be what? It's going to be negative 2x, okay, negative 2x plus 4. This is the f prime. You let it equal to 0 to find the possible max or the mean. So that gives us a negative 2x plus 4 equal to the 0. Okay, you solve for x, so that gives a negative 2x equal to the negative 4. Then you find the x is going to be negative 4 divided by negative 2. So that make it to the 2. Okay, so this is going to be your critical number. Critical number is equal to 2. Any question? So this is for the candidate. This value is a candidate for the maximum and the minimum, but you have to test it. How do you know that? How do you know it's not the minimum? Okay, so that's an important part of these type of problems, testing. You have two choices, first derivative test and the second one. Remember? The second one is easier for this type of problems because this is the first derivative, you see. The second derivative, f double prime, easily would be negative 2. F double prime, you know that that's a concavity. Okay, so you have to test it. So this is important part of the problem. So what is going to be your test? Testing. First or the second, we are going to use the second derivative test because it's easier. So for the second derivative test, you see this is your f prime. So we find f double prime. F double prime of x, you see it's a negative 2. Officially, you have to substitute to 2, but it's already negative 2. So negative 2 means this is always negative. Remember, f double prime is a concavity. So negative means what? Negative means this graph is going to be concave down. And remember, when it's a concave down, we get a maximum. Okay, so by the second derivative test, you get this fact that you are going to have a maximum here. Okay, so f double prime negative means done. So simply this will tell you that f, okay, f has a, okay, we put it here. So this is going to be the case. So f has a max. F has a maximum at x equal to 4. If you don't confirm it, you lose points on the test. Remember, that's a calculus part. Okay, so at x equal to 2, sorry, x equal to 2 that we got over here. So we confirm that we get a maximum at x equal to 2. We need to find the value of the y. Remember, y was what? Y was 4 minus x. So when we get x equal to 2, we are going to substitute y was equal to the 4 minus x. So that gives you 4 minus 2, and the result will be 2. So if you get x equal to 2, and you get y equal to 2, then you are going to be sure that your rectangle would have a maximum area. And you know that when x is equal to 2 and y equal to 2, so you are going to have a what? You are going to have a square. So this means if you want to make a best of that 8 inches wire to get there, to get the maximum area for your farm, for your fencing, you must bend it into the shape of shape of the square to get, to get these numbers done. Okay, how can I tell to use the second derivative test? I just have a look. It's easier. That's it. This is your function. There's the second derivative test because it's easy to find the second derivative of this function. The first derivative is more involved because the first derivative you have to give us a chart. And as you can see, you see the second derivative, nice, -2. -2, and automatically that gives you the concavity. Okay. If we usually test this with the second derivative test because it's easier. If we cannot use the first derivative, second derivative test, then we go to the first derivative. Okay. So that's the case for this one to get these numbers. You are going to see, okay, the natural log function in future. Sometimes for those type of problems, that would be easy, but for the time being, that's the best, okay, the easy test to apply. Okay, so that's going to be one. Any question? So that's an abstract problem, okay? If this is historic, that's a piece of history in not only in calculus, but in mathematics. You see, this problem was a kind of geometric problem. If you want to make it into the geometry, so what this problem is about is, you see, the way it was done by the Greek. Just move this one a little bit so I can move it. You see, the way this problem was done by the Greek, they used geometry. So what they proved that, you see, look at this one. So remember, the perimeter was okay. The perimeter was okay. We just add these numbers to get the perimeter. So the 2x plus 2y that make it here. So this will tell you that among all the rectangles, with a fixed perimeter, because the perimeter was given to you, among all the rectangles with a fixed perimeter, one with the maximum area is a square. That's it. That's a theorem in geometry in the Greek literature. And this was the one that, they did it. But in the case of the calculus, we change it into this format. Okay, any question? So that was just for you to get the idea of how we do the abstract. Of course, the way the Fermat did it, the problem is a little bit more involved than this one. The way it was done by the Fermat, just for your information, what he did, you see, that was a piece of wire. He just cut it into two. You see, that was a piece of wire. He cut it into two. He made a circle and a square. You see, a circle and a square. The radius of the circle was r. The side length of the square was x. He wants to find the side of the x and the radius of a circle so that the total area of the square and the circle to be a maximum. That problem is a little bit more involved. It's not bad, it can be done, but it's more interesting. This is the way we do it in calculus 1, 2, 3. If you do this one, you arrive at the fact that this Rx would be 0. So you can only get a circle to get the maximum, but I change it into this form. So that would be easier for you to, because it's not part of your deal to get this type of problems. Okay, so that is abstract problem, nothing to do with the application. And now we're going to change it to the one that you are going to use. Okay, any question? Get the idea. The idea is going to be a problem would be given to involve the max and the mean. So you have to create a function. Okay, you create a function. As soon as you create the function, the rest is calculus. You find the derivative of a function, you let it equal to the 0, you get the critical numbers, okay, and then you test it. You test it by either a first derivative test or the second one. Now, in business, the way we are going to do it, we are going to have 3 cases, okay? We are going to have a profit function, a revenue function, okay? These are going to be the one. So what I'm going to do, I'm going to give you one from each, okay, to see how we're going to apply these type of problems in business. Are you ready? It can be used, in physics, geometry, biology. So it depends where you are, the application of calculus. Now, I do the revenue problem first. You are familiar with the revenue problem, revenue function. We repeat it again, but the thing that we're going to ask you is going to be different than the one you did before, okay? So this is going to be your first job, problem number 1. So that was for get the idea. So the problem number 1, we call it maximum revenue problem. Maximum. Okay, maximum revenue problem. Revenue problem. So what's going to be a situation? A situation would be created. In this case, we are going to selling something like a video phone. Okay, so I have to explain the problem. So what's going to be a problem? A company. Okay, a company manufactures and sells X video phones. Okay, a company. Okay, that's it. The company manufactures and manufacture and sells X number of video phones per week. Okay, so X is going to be the number of as we did it before, the number of the production, if you like. Now, the weekly, as we did it before, we need a price demand equation to be able to find the revenue function. So the weekly price demand, as in your previous test. So price demand equation. Equation is this is it. So we have the price, and this is going to be equal to the 500 minus 0.5x. Okay, so this is a relationship that we have. So what is going to be the question? The question is going to be, so this is going to be the part 1. For part 1, we want to know what is going to be what is. Okay, what is going to be the maximum? What is going to be the maximum weekly revenue? Okay, that's the first part. And so this means you have to find the revenue function yourself. Remember, R of X is X times P. It's like the one that I did. You have to have a function. So the function is going to be revenue function. So you find it yourself. So L of X would be X times P. And then when you find it, you differentiate it, you let it equal to 0, and eventually we get the maximum revenue. Okay, that's the first part, dollars. Now there is always a second part for these type of problems. What's going to be the second part? The second part is how we're going to make this maximum revenue. So we're going to make it by selling. So selling what? How many numbers? So how many numbers are going to sell? How much are going to cost in order to get that maximum? So that's going to be the second part of the problem. So the second part of the problem is always this, two parts. You are going to find out what price. Okay, what price should the company? What price should the company? Okay, what price should the company charge? Okay, charge for the phones. Okay, charge for the phones. And how many phones they should prove they should sell or manufacture, and how many? So that would be dollar, the price of each. And okay, and how many phones they should produce to get this maximum? Okay, should be produce. Okay, should be produce. Should be produced to maximize this revenue, or to realize it, if you like, to maximize the weekly revenue. Okay, the weekly revenue. Okay, this is revenue. See, that's going to be the question. So you have to determine the maximum. Okay, the maximum value would be money, the revenue that you're going to collect. And you have to tell us how we are going to collect it. So we're going to collect it by selling. How many should we sell? X. Okay, and how much should be cost? So how much should be charged, the price? Okay, to get these numbers. Okay, this is the one we call it a revenue problem or maximum revenue. Read it carefully. It's a revenue. There's going to be one, we call it profit, and this is going to be the revenue. So this is going to be the revenue. Okay, any question? Are you ready? That's it. Solution. Part 1. You have to get the revenue function first. And you know that the revenue function is R of X is going to be what? X times P. That's a formula that we gave you before and we used it. So P is given to you. Substitute. So it's going to be equal to the X times P. X times P would be 500 minus 0.5X. Multiply together, so that give you 500 X minus 0.5X squared. We can also find the domain, but in your book, they don't find the domain, so I'm not going to push for that one. Okay, so R of X is going to be equal to, if you like, you can rewrite it if you like, or just keep it as is, negative 0.5X squared plus 500X, okay? You double check this one, because if you make a mistake here, the rest of the problem would be out. So just check, make sure that everything is all right. It's not going to be complicated one, you just multiply these two together. So that would be the revenue function. Okay, now you want to maximize it. From now on, it's just a calculus problem. A function is given to you, you want to find the maximum of this function. You know that, you have to find the critical number. Okay, so we started the R prime of X, carefully differentiated. That gives you 0.5 times 2, that gives you just 1. So it's going to be negative x, okay, and the derivative of 500x would be just 500. So that would be the derivative r prime. Okay, exponent times coefficient, 2 times 0.5 would be just 1. So this is going to be the r prime. You let it equal to 0. Okay, r prime of x equal to 0. So that gives us a negative x plus 500 equal to 0. So x would be 500. That's it. So this would be your critical number. Okay, so the critical number is going to be equal to the 500. Okay, you find the critical number, and then what you are going to do is you are going to test it first. Remember, you have to test all these problems. You test it because you are looking for a maximum. If this give you the maximum, then you are going to find the maximum value. Okay, so we have to test it. So the question is going to be testing. Then you look at your function, you see r prime, easy to differentiate again. So we are going to use the second derivative test. Second derivative test for this easy function, which is a negative x plus 500. So we differentiate it again. Okay, this is 500. Differentiate it again, r double prime of x would be a negative 1. Negative. This is concavity. Okay, negative means done. And the done means maximum. Okay, so you confirm that the r of x has a maximum. Has a maximum at what? At x equal to the 500. Remember, x is the number of the phones. So you are going to produce 500 to maximize. So what is going to be the maximum revenue? So the maximum revenue would be what? Would be r of 500. Remember, you have to find it because they ask for the maximum revenue. So go to the r of x and substitute. This is your r of x. You substitute, replace x by 500 to get the money. So this is going to be equal to, okay, it's going to be equal to the negative 0.5. 0.5x squared, which is going to be 500 squared. Okay, plus 500x going to be 500 times 500. Okay, you just plug in to get this number. So we have to square the 500. So it's going to be negative 0.5. Okay, negative 0.5, and that would be 2,500 or more. Sorry, you get 4 zeros. Quite a lot of money. Okay, so it's going to be 250,000. And over here, 5 times 5 would be 25. We get a 25 with the 4 zeros. 1, 2, 3, 4. Okay, any question? Just the algebra. So multiply. 5 times 25 would be 125. Okay, it's going to be negative 125. And you are going to have the 4 0. You have 1 decimal here, so you can drop one of the zeros. So that can be negative 125,000. You can use your calculator. And this is going to be what? And this is going to be 250,000. Okay, this is 125. This is 250. So when you subtract it, the leftover is going to be 125,000. So the maximum revenue, money. Okay, the maximum revenue, dollars, is going to be $125,000. This is the first part. Any question? And as I told you, it's not a difficult problem, but it takes times, and you got to be careful, okay, to get these numbers done. So yeah, you'll be able, okay, you'll be able to do it, to get this done. Okay, so this is exactly what we did. It's always the case, you know, the price demand is given to, which is a P. So R of X equal to the what is going to be X times P. You get the function, then you differentiate it quickly, nicely. You let it equal to 0, we get a critical number, you have to test it. We test with the second derivative test. Okay, R double prime happened to be negative. So negative means concave done. So we confirm that we get the maximum. Then we drop it in to get the maximum value. That's the first part. Any question? And there is a second part. The second part is how we're going to collect this money. Okay, so how many items, how many units, in this case phones, the company should produce and how much the company should charge. How many produce is already done? You see, 500. So the company should produce 500 phones per week. How much are going to charge? This is it. This is the formula for the price. So you put the X equal to the 500 here, you get the price. Okay, so that's the first part. Now the second part. So for the second part, this is how we're going to start with. We are going to start to say that they know the company. Okay, the company should produce 500 phones per week. Should produce, or manufacture, sell, should produce X equal to the 500. It's the one they usually have it from the first part. Okay, so the company should produce X equal to the 500 units or phones. Phones, okay, per week. And how much they should charge. And should charge. Okay, what's going to be the price? Price P equal to the price demand equation equal to the 500 minus, it was 0.5x, but 0.5 times x. What is the x? X is 500. So this is going to be 500. And this is going to be minus 5 times 5 would be 25. We have 2 zeros. It's going to be negative or minus 250. 250, this is going to be, okay, $250. $250, okay? So should charge, this is it, should charge $250 per phone or per unit, per phone, okay, to maximize the weekly revenue. And that would be the end of the problem. Okay, it's very standard and very useful problem that give you the nice application of whatever we did so far. Okay, any question? So that's a revenue problem. You see, you did have the revenue problem on your previous test, but we just asked for the marginal revenue, remember, R prime, and we asked you to test it, at a couple of numbers. But this is going to be the maximum revenue problem. You form the revenue function, you let it go to 0, and then that give you the result. Okay, that's a revenue. We don't usually have cost for this type of problems. Okay, we can have it, but we already talk about the costs when we talk about the rate of change. So the next case is going to be the profit function. The profit function is the situation will be created, price demand will be given. They have to give you the cost too to be able to find the profit. Remember, the profit function is the difference between what? Is the difference between revenue and cost. Then you do the same problem for the profit. Okay, so let's give another one. Okay, so that was the revenue problem. Now we are going to have a profit back. Okay, that's one. To get these numbers. Okay, any questions so far? So we give you another one. We go to the profit problem. So what is going to be the next example? The next example is going to be maximum profit problem. Make sure don't be confused when you read the problem. Read it carefully. Which one is it? Is it the maximum revenue or it's going to be maximum profit? In the case of the profit, they have to give you the cost function. So if you see the cost function, you realize that this is a profit problem. But if it's only the revenue, if only the price demand is given to you, so we can go as far as the revenue function. Okay, let's see what we are going to sell now. We are going to check another company, and then we are going to sell digital cameras. Okay, so there you are, a company. Okay, a company manufacturer. Okay, a company manufactures and sells, this time manufactures and sells X. This time is a digital camera, okay? Digital cameras. Digital camera per week. Per week. Okay, this is the situation that we have. So they have to give you the price demand and the cost function. So the weekly, okay, the weekly price demand. Price demand. The weekly price demand and cost. Price demand and cost equations. And cost equations are given by the following equation. Okay, so two equations must be given. For the price demand at this time, P is equal to the 400 minus 0.4x. That's the price demand. For the cost, and the cost function, we have $2,000 plus 160x. Okay, so we have the price demand and we have the cost function. Okay, what do you want? First part is going to be, let's say, the first part. First part is what is the maximum profit? Okay, what is the maximum? What is the maximum weekly profit? Okay, this one, what's the maximum weekly profit? That's the first part. And this is the money. Okay, so we have to form the profit function. We need the revenue function first, then the difference between revenue and cost give us the profit function. Then we have to differentiate it, let it equal to the 0, get the credit card numbers, test it, eventually we get the money. But there is a second part, like the one that we did. How we're going to collect this money? We collect it by selling how many and charging how much. Okay, the same thing. So again, the same thing is going to be what price? Okay, what price should the company? Okay, what price should the company charge? Okay, company charge for the cameras. Okay, charge for the cameras. Okay, and how many they should produce? and how many cameras. Okay, how many cameras should be produced? Okay, how many cameras should be produced to maximize that profit? Okay, should be produced to maximize or to realize. Okay, to really realize that the maximum weekly, the maximum weekly profit to get these numbers. Okay, so it's very similar to the revenue problem. That's why I'm telling you that read it carefully and don't do too much. Some people, when we get to this one, they do the revenue, R prime, they come back to do the profit. No, it's a profit problem. We're just focusing on the profit function. Okay, are you ready? We need the revenue function again, because in order to get to the profit function, you need the revenue function, okay? So this is going to be the solution for the part 1. So start with the revenue function again. So the revenue function R of X is X times P. Substitute. It's going to be X times P, and the P is 400 minus 0.4X. Okay, you distribute it carefully. It's going to be 400X minus 0.4X squared. So that would be your revenue function, okay? So your R of X, if you like, you can switch it. You don't have to. It's going to be negative 0.4X squared and the plus 400X. So this is going to be your revenue function. But remember, you're not to do anything to this one because that's a profit problem. Okay, so you continue to get the profit. Now the profit function, you see, the profit function P of X is the difference between the revenue and cost. Okay, now we substitute. That's the revenue function, and the cost function is given to you. So it's going to be equal to the R of X, which is a negative 0.4X squared plus 400X minus, you must open up the parentheses. Most of the people, they miss this one. They don't open up parentheses and they miss a negative sign and everything would be different. Okay, we bring the cost function. The cost function is given to you. This is the cost function. So it's going to be minus 2000 plus 160x. Okay, apply this negative sign carefully to get your profit function. So it's going to be equal to, okay, it's going to be equal to the negative 0.4x squared. Okay, plus 400x. Now apply this negative sign, it's going to be minus 2000. And this is going to be minus 160x. That's the one that I'm talking about. You see this negative sign, you have to apply it twice to get to these numbers. Any question? Combine the like terms if you have any. You have a 400x and over here you get a 160. So this should be done. So the profit function is going to be what? It's going to be negative 0.4x squared. Okay, 400 and 160, you subtract it, so that give you a plus. Okay, and that give you 240. Yes, that's it. That give you 240x. Okay, because it's a 160 out of 400, so that's it, minus 2000. So this would be the profit function. Any question? Now we can start talking about the calculus part. Because you need what? You need a maximum profit. So you have to differentiate this function, okay? Nothing to do with the revenue function this time. Any question? So I have to go to the next page to get this part. So I can differentiate it here because that's easy. So differentiate it carefully. 0.4 times 2 would be 0.8 minus 0.8x, and this will be plus 240. Carefully differentiate it. So that gives you P prime. You let it equal to 0 to get the critical number, then you are going to test that. Okay, any question? So I'm going to the next page. I let P prime equal to 0 to find the critical number. Then I test that. If it's going to be the maximum, then I can go on, okay? So let's go to the other page. So what we are going to do is, we are going to let the P prime of x to be equal to 0. Okay, but the P prime x was a negative point, okay? It's a negative 0.8x. Negative 0.8x, okay, and the plus 240, which is equal to the, okay, it's going to be equal to the 0. You solve for x, so that give you what? That give you a negative 0.8x is equal to the negative 240. Then you divide by negative 0.8, so x would be equal to negative 240, and it's going to be negative 0.8. You know, you can use your calculator, or you can drop the negatives, and there is 1 decimal here. You put 1 zeros on the top. If you want to do it without calculator. So the result would be 300. So x equal to the 300 is going to be your critical number. Okay, so the critical number is going to be 300. Any question? So this is the candidate. You know that you have to test it. Which tests are going to go for it? Second or the first? Second, of course, because it's easy. The function. Okay, so testing, make sure you test it. Testing. We go with the second derivative test. Why? Because the P prime of x is very easy function. It's a negative 0.8x plus 240. Okay, nicely differentiated. If you get a second derivative, so the second derivative would be simply negative 0.8 because derivative of x is 1 and this is 0. So which is negative? It's concavity, negative means none. So we have a maximum. Okay, so P of x has a max. A maximum. Okay, a maximum at what? At x equal to the 300. So we need the confirmation all the time. Okay, any question? Now, money, we can find it. What is the maximum profit? Maximum weekly profit is equal to, okay, it's going to be equal to the P of 300. You go to the function, you see this is going to be P of 300. You go to the profit function and you substitute. Remember the profit function is it? The profit function was negative 0.4x squared. Now it's going to be 300 squared. Okay, and plus 240x plus 240 times 300 and plus 2000. Okay, you already got the profit function, then you substitute to get the money. So we have to square this one first. So it's going to be negative 0.4. And that would be 90,000. Because 3 squared would be 9, we get the 4 zeros. And this is going to be plus 3 times 240. Okay, that gives you 72,000. And that would be 2,000. Okay, continue. 9 times 4 would be 36. It's going to be negative 36. You have 4 zeros, but you have to drop one of them for the decimals. So 36,000, 72,000, and the 2,000. So that gives it 36, 38,000. 38,000. So money, the maximum profit is going to be equal to what? Dollars. And the dollars is going to be 38,000. So that gives you the maximum profit, the money. Any question? Since it take a little bit more time to find the profit function, and then you substitute. You got to be patient to be able, to apply it. Okay. What is the negative 2,000? Is it negative? Oh, okay. So less money. So it's a negative, and this is going to be negative. So we have to take out 2,000. Okay, so it's going to be 36,000. That's it. That give you 36,000. Thank you. Less money. Okay, the 2,000 was negative, so I rewrite it here. So the maximum profit is going to be $36,000. That's the first part. Okay, second part is like the revenue. I'll give you a break. I'll come back and do the second part for you. Okay, so be careful, as I told you, not difficult problem, but it takes time. Just make sure don't miss anything, and especially for the profit function, it's a profit problem. You see, some people, they do the revenue, this one, and then come back to the profit. It's going to be a huge problem to get all these numbers around, okay? So that's going to be the maximum. Then the second part is the same as the revenue one. You already got the X, you have to sell 300, okay, 300 cameras. You need a price. You can, just substitute the price demand to get the numbers, okay? So it's 8:23. So we get a 10-minute break and we come back and we finish the second part. And of course, there is another problem for the revenue function, and we're going to check that. Okay, see you then. Okay, we're back. And I think this last one is 36, okay, and it must be 34. Yes, because this is 72, 36. That give me 36 minus 2000, it's going to be 34 eventually. Okay, because that's a negative. Okay, you subtract these two, that give me 36 minus 2000, which is 34. So, you know, just correct this one. Okay, I think that's right. Okay, so this is going to be the first part. Now we are going to continue to get the numbers. Yes, it's 34. Thank you. Okay, so that's the first part, the maximum profit. So the question is going to be how much are going to charge? Okay, how much are going to charge? How many are going to manufacture? The second part. So that was the first part. The second part was the part. Okay, and this is it, the part two. The part two, we know how many are going to produce because we got the X equal to the 300. So we're going to explain that the company, okay, the company should produce or manufacture, produce X equal to the 300 units. In this case, cameras. Okay, cameras and the price, and should charge the money, the price equal to the price demand. What was the price demand equation? So the price demand was 400 minus 0.4. 400 minus 0.4 times the X is 300. Okay, we go to the price demand equation, we substitute to get this number. So this is going to be 400, and this is going to be 1200, that's going to be minus 120. Okay, 120, and you subtract it over here, so that give you 280, I think that's one. Okay, so the price that they have to charge. Okay, so the price that they have to charge is going to be dollars. Okay, $280 per camera, per unit, per camera, to maximize the profit. So maximize. Okay, to maximize the weekly profit, weekly profit. Okay, so this is a situation we're going to have for the maximum profit function. Okay, any question? So this is the profit function. The other one was the revenue function. And now there is another version of the revenue problem that we like it. You see, when you go shopping, sometimes they try to attract more customers. So sometimes they offer a discount, okay, rebates, this type of ideas. So we are going to check those type of, this is very classic, because the equation is classic. You see the revenue function is X times P. You get all the profit function is classic one. But this new format is the way you create the revenue function is a little bit different, the way you design it, okay? So it's very popular. So that would be the third case, okay? So I give you one, and you have a couple of them, you know, in your practice one, take home one, then eventually we get more, okay, more examples. So that would be the third one. It is a revenue problem, okay? So we usually either give you a revenue problem of this format, the new one that I'm going to discuss, or the classic one that we already talked about it, okay? So it's going to be two problems for each test or quiz. either a revenue or the profit. Profit is a standard. You see, this is the one we did. But revenue can have this type of format, which is quite interesting one. Okay. So you're selling something, sometimes you reduce the price, you make it more customers, or sometimes you increase the price. If you increase the price, you will lose some customers. So we want to know how far are you going to go when you want to give a discount, 10%, 20%. But at the same time, you are not going to lose money. So you would like to offer the discount, but you want to get the maximum revenue of this, of your action. So I'm going to give you one here, and we have more when we get to the, okay, to your practice one. This one is going to be somebody selling something. Okay, so let's say a business in this case, a business or whatever sells, okay, a business sells 2,000 units, or whatever it is, okay, units of a product, 2,000 units of a product, per month, okay, per month, at a price of $10 each. Okay, $10 each. You see, if you sell 2,000 units and you charge $10 for each, so what's going to be your revenue? Your revenue would be what? Would be 2,000 units times 10, which is going to be $20,000. So if you stay with this pattern, if you like, if you stay with this one, at the end of the month, you are going to make $20,000. Now you want to make more. So how are you going to make more? You are going to offer a discount. So it can be, okay, so it can sell if you like. It can sell 250 more items. Okay, more items of whatever it is. Okay, items per month. Okay, items per month for each 25 cents reduction in price. So I'm going to write it down in dollars, 0.25 or just 25 cents. A reduction, okay, reduction in price. That's it, reduction in price. Okay, so anytime you reduce the price, by 25 cents, you are going to get what? You are going to get 250 more customers. So the question is going to be, what price should give you a maximum revenue? Okay, so the question is going to be, this is it, what price? So you want to know how far are going to go. What price? New price, if you like. What price per unit? What price per unit will maximize? Okay, will maximize. Will maximize the monthly revenue. The monthly revenue. Okay, the price, and sometimes they ask for what is that maximum revenue? Okay, so what is maximum monthly? Usually ask for just that price. In this problem, we ask also for the revenue. Okay, this is, we call it the type 2 problems for the, okay, the type 2 problems for the revenue function. Okay, so basically what you are going to do for these type of problems is you already got the price. You see, you already got the price, $10, and the number that you sell, which is 2,000. Okay, and your revenue would be 2,000 times 10. So what you're going to do is you are going to create a new price. You are going to create a new price and the new number of units. So if you get the new price and the new number of units, you multiply them together, that give you the revenue function again. Then you can maximize it. So for this type of problems, because you want to know how far are going to go the reduction. So what we do to set up the problem is going to be the following. You have to take the x. The variable is going to be the number of the time that you are going to reduce your price. Okay, so you're going to suppose the x is going to be the number of the time that you're going to do this reduction. X is the number of, okay, it's going to be the number of 25 cents reduction, number of $0.25, okay, reduction in price, reduction in price. Okay, your x is going to be your new variable, is this one. And then what you are going to do is you are going to find the new revenue. See, this is going to be the one, just for your information. You see new revenue is going to be what? It's going to be new price. It's going to be new price times it by new number of items. Because you already got the revenue. You see, your revenue is $20,000. But if it's going to be a new one, so you have to calculate it if you like. So this is going to be our revenue function. So R of X is going to be equal to new price. What's going to be new price? So what was the original price? Original price of each item is $10. $10. 10. So what you did, or what you do, you reduce the price. How much? 25 cents. How many times? X number of the times. So your new price is going to be $10 minus the reduction. Reduction each time is going to be 0.25. But how many times are going to do it? X number of the times. So this is going to be new price. Any question? If you increase the price, it's going to be, the old one plus. But since you reduce it, it's going to be $10 minus 0.25x. Okay, any question? Times the number. So what was the old number? So previously, what you did, you sell 2,000 units per month, 2,000 units. But what will happen now? It's happened that if you offer the discounts, you get more customers. How many more? Anytime you reduce the price, you get 250 more customers. How many times? X number of times. You see, this is going to be your function. And you must be careful that, you put these numbers and the dollars, in proper place to get it, okay? So this is going to be a new revenue that you're going to collect. You collect it with the new cases. The new cases, what's going to be your price and what's going to be your number of the items that you're going to sell. New price is going to be the old price, which is $10, but you offer a discount. How much? 25 cents. How many times you did it? X number of the times. So 10 minus 0.25X is going to be new price. How about the number that's going to sell? Previously, you used to sell 2,000 units per month. But now you get more customers. How many more? 250. How many times? X number of the times. You see, this is going to be a revenue function. And you just simplify it and then differentiate it, and you get the numbers. This is going to be, yes, of course, it's a new revenue. This is going to be new revenue. Okay, any question? So to work with this function, you better FOIL it. Okay, create a function first and then start differentiating it. That's going to be, so this is going to be a new revenue. And we call it the revenue function, and the X is going to be number of the units. You have to use the FOIL method. Okay, FOIL it, multiply the 10 by this, and then come back. So it's going to be equal to, okay, that give you 20,000. Okay, and this is going to be 2,500 X. Then I multiply this inside, it's going to be minus. Okay, 2 times 0.25, that give me, okay, that give you 0.5. Okay, 0.5, and we have 3 zeros. Okay, so it's going to be 50. Okay, this is going to be 50 or 500. So that give me 2 times 0.25, that give me 0.5, it's going to be 500. 500x. Okay, then I multiply these two together, that give me minus. Okay, 25 times 25 would be 625. 625 with the 0, but we have 2 decimals over here, so that will give us a 62.5. Double check, make sure you get it right. When you do it on the test, this is it, x squared. Okay, I just FOIL it. Combine the like terms, rewrite it if you like. So R of X is going to be equal to, so I have only one X squared, so I pull this one here, it's going to be 62. Okay, 62.5 X squared. Then I have this excess to 2,500 and the 500, that make it to 2,000. So that would be plus 2,000. Okay, 2,000 X. And for the numbers, I have 20,000. So that give you 20,000. That's going to be a revenue function. Okay, the only restriction is that, of course, X is positive. Because the X is the number of the, okay, X is going to be number of the time that you're going to change the price. Any question? You see, this problem is going to be interesting because you have to find this revenue function. Some people, they would be confused. They put these numbers in the wrong position. Okay, read it carefully. You reduce the price, so this is a negative. You increase the number of the customers, it's going to be positive. And sometimes you increase the price and then you may lose customers, okay? So be careful. It depends on the type of the problems that would be given to you. So from now on, that's it. What do you want? You want to maximize it. So we have to differentiate it, okay? So carefully differentiate it. It's going to be R prime of X equal to, okay, and that's it. Exponent times coefficient. This is it, 2 times 62.5. That give you 125. So it's going to be minus 125x. Okay, and derivative of 2000x would be just 2000. Okay, this would be our R prime of X. I'm going to highlight it because I'm going to use it. Let it equal to the 0. So R prime of X equal to the 0. So that will give us a negative 125x plus 2000 equal to the 0. You saw for X. Okay, so it's going to be the result. It's going to be negative 125x equal to the negative 2000. So your X would be simply X is equal to, so we have a negative 2000, and this is going to be negative 125. Okay, so if you divide it, that give you 16. You can check it with your calculator. Okay, so it's going to be X equal to 16. So this is going to be the number of the time that you're going to increase or decrease the price. So this would be a critical number for this function. You are looking for a maximum. You have to test it, remember. So testing. Again, this is R prime. So the second derivative test is the best. Second derivative test. Why? Because I have the R prime easy function, which is negative 125. Okay, negative 125x. And I have the 2000. So easily you differentiate it to get the second derivative, R double prime of x, which is going to be equal to the negative 125. And this is a negative number. And R double prime, you know that gives you concavity. So negative means done. So we have a maximum. Okay, so R of x has a maximum. At x equal to the 16. Okay, so what they ask for the maximum price and the maximum revenue. Now, the new price is going to be, okay, the price. Remember the original price was $10, you reduce it, you see that's the one. $10 minus 0.25x. So this is going to be $10 minus 0.25x. So it's going to be equal to, we get a 10 minus 0.25 times 16. Okay, it's like a quarter, so that gives you 4. So it's going to be 10 minus, okay, 10 minus 4, which is going to be equal to the 6. So the price, that new price that you're going to charge is $6. Remember, originally the price was $10. So this means if you offer $6 for a price of the item, so in that case, you are going to make money, lots of money, the maximum revenue. They usually ask for the price, which is $6. But in this problem, they ask also for the maximum revenue, so we continue, okay? If they just ask for the price, at what price, the maximum revenue would realize, you're done. But in this case, they ask for the revenue, so this is it, maximum revenue. That would be R of 16. So you have to put the 16 into the function, original function to get it. Okay, this is original function. You have to use your calculator to get this number. Okay, so R of 16 would be, if you substitute negative 62.5, you have the x squared, which is going to be 16 squared. Okay, 16 squared plus 2000x, so it's going to be 2000 times x, which is a 16. Okay, 16 plus 20,000. 20,000, that give you the money. Again, if they ask you to do it, you just go ahead and do it. You can use your calculator to get this number. Okay, I have something like 36,000. You can check it for yourself. Okay, so that give you $36,000. This is going to be the maximum revenue. Okay, so the maximum revenue, again, if they ask, your new revenue would be 36,000, which is very good, because originally you're making only $20,000. But with this new price, you make more money. Okay, so that's a type 3. This type is very popular for the revenue function because, you know, just put the things together and get the function yourself. So you have a couple of them in your practice one that I posted for you, the take-home one, and you have some very nice one in your book to get these numbers. Where did you get the 20,000 from? This is your revenue function. Okay, this is R of X, and we got it, we know that we got it from that Boyle method that we did. So again, this last part, they don't usually ask for it, but we are ready for it, to get this number. And when you find it, make sure that makes sense. You see, originally the price was $10. So you reduce it to the $6, which makes sense. So if you got something like $12, $15, so this means you made a mistake. You have to go back and double check it, okay? But a very popular case for the revenue function. Okay, give you a better understanding of what's going on. When I teach calculus 1, 2, 3, I just give them one of these, okay? Because I cannot give them, the profit and the revenue function is a classic type, if you like. So we are going to get the practice again to be able to do these type of problems. Okay, any question? So that's a 3.4 and the 3.5, the optimization problems that we have for this case. Again, I avoid giving you any other examples. You have some in your book, but it's not part of your deal really. So you should be able to do this type of problems for us. Okay, so 2 on the next quiz, 1 profit, 1 revenue, and 2 on the test, and we usually give you 1 of them on the final exam, okay, of this revenue problem. We are going to have the revenue over and over again to get these ideas to take us through it. Okay, any question? Now, what else we are going to supposed to cover in this chapter? Now, there is one more concept, and what is that one is going to be if you want to graph a function in calculus. You see, today everybody uses cell phone, graphing calculator, etc. to get the function, to get the graph of the function. But if you want to be serious about it, it's quite a lot to be able to graph a function. In order to graph a function, other than the graphing one that we can leave it and say, okay, do it using graphing calculator. But there are a couple of concepts that's going to be useful, is related to the previous part of calculus. Your book, remember when you talk about the limit of a function, your book, there was no limit at infinity, if you like. In order to sketch the graph of the function, you need that concept. We usually teach it at the beginning, but I just went with your book. So in your book, this concept is coming in section 3.6. It's a very easy concept. Okay, so we are going to check that one too. And for the graphing one, we're just graphing, easy polynomial, nothing else. When we get towards the end of the course, there are a couple of more examples that we may have to try that one. But basically the graphing one, we analyze the graphing calculus rather than, checking it. But I tell you what I'm going to do with this. So let's see, we got a little bit time. We can give you introduction to that one too, so that we'll be able to finish that review for you, okay? So if you want to graph a function, you see, I've done it in algebra. You need to collect some points, X and the Y intercepts, these type of ideas. But in your case, we work with the polynomials. The domain of the polynomials are all real numbers. Remember, from negative infinity to positive infinity. Negative infinity and positive infinity are not numbers. They are just indications. When you say positive infinity, means this is increasing without bound. This means if you think about any number, I can give you another number which is greater than yours. That's the meaning of positive infinity or the negative infinity. So you want to know what is going to be the behavior of the function, mostly polynomials, when you're dealing with these big numbers, if you like, okay? So that's the idea. We call it limit at infinity. It's an easy concept, but it helps you quite a lot. Help you with, some of the other parts that we discuss. So let me just give you a little bit of this idea and we finish it on Thursday, and we go over the review for you. Okay, that's one. So we may not be able to get, so that's a 3.6 and the 3.7. We may not go through 3.8. We are not going to rush it, and we can do it later. Okay, so what is the idea of this 3.7? It's a quite interesting one, quite useful in some other, that gives some shortcuts for some other problems that we did before. Okay, just a little bit tonight, and then we finish it on Thursday. 3.7. What's going to be 3.7? We are going to have what is going to be the, we are going to see what is going to be the limits at infinity. You did the limits at the numbers at the beginning. So what's going to be limits? In your book, they talk about asymptotes. It's the same thing. But the more technical point is this one rather than the asymptotes. Asymptote is geometry. What is limit at infinity? Limit at infinity. To get the good idea, the concept, the title that I usually refer to this one is, I like this one, because that is what will happen, or in the behavior, I call it, or and that's much better. Behavior. And behavior of a function. Because of the polynomials. Remember, the domain is negative infinity to positive infinity. You're just checking that end of the function. Okay, let's see what does it mean. The definitions, okay. We can give you a short formula and you memorize it, but we prefer to get to the concept first. So the behavior, just introduction tonight, and then we finish it next time. The behavior, okay, the behavior of a function, f of x. The behavior of the function f of x as or when x increases. Okay, as x increases or decreases without bound. Without bound means forever. Okay, increases without bound means x goes to positive infinity. Decreases without bound means x goes to negative infinity. Okay, this is going to be called, it's called end behavior. Or its end behavior. It's called its end behavior, or the end behavior of the function. End behavior. Okay, so when it's getting bigger and bigger and bigger. Now we have a notation for it. When x increases without bound, when x increases. Okay, when x increases without bound, we write, that's it, we write x goes to positive infinity. So x goes to positive infinity means x is bigger than anything you think about it. That's it, x increases without bound. Okay, any number you think about it, x is going to be bigger than that number. Okay, and when x decreases, when x decreases, okay, when x decreases without bound, decreases without bound. So this means x is going to be less than anything you think about it. We write, okay, we write x goes to negative infinity. Okay, so that is going to be the notion of the positive infinity and the negative infinity. So to explain it, we use the limit. It can be done in college algebra, okay, and we do it, but without the notion of the limits. We use the limit of f of x, x goes to positive infinity, and limit of f of x, x goes to negative infinity. You see, you need these two for the graph of your function at the end point. So we use limit of f of x, x goes to positive infinity, and limit of f of x, x goes to negative infinity to explain it, to study. Okay, to study and behavior of the function and behavior. Okay, and behavior of the function. Function f. Okay, so that's the idea of this section. Again, as I told you, because you want to graph it. If you want to graph, yes, you put x equal to 1, we get the y, x equal to negative 2, we get the y, but the domain of the function is from negative infinity to positive infinity. So what will happen if this x going to positive infinity, okay? And what will happen when x goes to negative infinity? So it should give us, some idea for this type of behavior of the function. Okay, so just one example, then we continue next time. There is a theorem to take care of everything, but I want just to motivate it first. We want to find each limit, you see, find each limit. So let's find this limit, you see, limit of, okay, limit of x cubed when x goes to negative infinity, and the limit of x cubed when x goes to positive infinity. You see, this is going to be the question. So we want to know what would happen to the x cubed when x getting smaller and smaller and smaller. X goes to negative infinity. And what would happen to the x cubed when x getting bigger and bigger and bigger and bigger? Okay, that gives you the direction of your graph to get these numbers. So what's going to be the solution? I'm going to use the graph to explain it to you. You see, look at this graph. This is the graph of the y equal to the x cubed, you see. This is y equal to x cubed. This direction is a negative infinity for x, and this is going to be a positive infinity for x. This, the top would be positive infinity for y, and this is going to be a negative infinity, sorry, for y. So when x goes to negative infinity, let's see what's going to be the direction of your graph. You see, get the number. If this is going to be a number, you have the negative number here. If you get this negative number, you see, if you pick a number here, this is going to be a value of the y. Okay. If you pick another number here, this is going to be the value of the y. So as you take x equal to the negative infinity, you see the value of the function would be down, 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 down. So the behavior of the function would be the limit of x cubed when x goes to negative infinity would be negative infinity. You see, that's going to be the one. Okay, so this is going to be the situation. This is going to be a situation we're going to have. So this means that when we want to graph it, you see, when we want to graph it, we know that we are going to start from here. You see, this is a negative infinity and negative infinity. And when you are here, we know that the direction of your graph would be down. See, the direction of your graph is going to be down. So this is the way we are going to use it when you want to graph the function. And we know that the graph start with the third quadrant because it's starting from here, just going up, up, up. Okay, that's the limit of x go. Or you can cheat really. This is it. You have a negative number. Negative cube would be negative. So the limit would be negative infinity. That. Okay, if you want to use algebra, but we want to understand it to get the idea. Okay, so what would happen on the other end? You see, on the other end, if x is a positive number, this is going to be y. This is going to be y. This is going to be y. So when x goes to positive infinity, your function is up, 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 up. So this means the limit of the limit of x cubed. When x goes to positive infinity, is a positive infinity. So if you want to graph it, you see at the preview your graph, this is a positive infinity and this is a positive infinity. You know that you're going up again here. You see, that will help you when you want to graph it. You know that this graph should start in the, this graph would start in the third quadrant and would end up in the first. Okay, so the starting point and the end point of the graph, you can identify it. That's the idea of the limit at infinity, to get these numbers for the polynomials. Okay, any question? So you can cheat. This is it. Positive to the third is positive, because infinity cube would be infinity. It's not, of course, a number. Okay, but when it's getting bigger and bigger and bigger, of course, the x cube would also be much, much, much more bigger and bigger. So we call it a positive infinity. So when it's a power function, you see x to the 4th, to the 5th, to the 10th, you just need this sign. Is it a positive infinity or is it a negative infinity? And that would depend on the power. This is 3. If you get a 5, 7, 9, 11, the same thing. But if it's going to be x squared, then the negative square would be positive. Okay, I'll give you more example next time to get these ideas. So this is how we use it for the graphing the function. We have one theorem would take care of everything, and that would be if you're given a polynomial, the limit at infinity is the same as the limit of its leading term, one of these powers. So I give you a couple of more examples and then I finish this one. Okay, that's it. Any question? So your quiz would be up to the 3.7. Okay, I finished this one on Thursday, and then I go over the practice quiz that are posted for you, and we give you the quiz on time. Okay, that's it. Any question? That's going to be the one. 3.6, yes, we already talked about 3.6, yes. Yeah, we have the 3.6, 3.5, 4, 5, 6. 6 is, what was 3.6? Yeah, one of these are 3.6, maybe this is, let me just check it. Because in your book, they give let me see what sections we are in. 3.7 is, oh, okay, this is 3.6, sorry. This is 3.6.